Hello, everyone. My name is Mohannad Mira, and my thesis dissertation was about the historic building information modeling from point cloud to the modeling of complex geometrical elements and thematic information. The study shows the work done so far for renovating a roof of a church called the San Giacomo Church in Como, Italy. It's part of renovation process for the church after like 3 renovation through its history. And this is the final one. And my dissertation will be divided into 6 points: the introduction, of course, and the assessment of the church itself, the architectural and structural features of the church or the building, the modeling process, and then the structural analysis for the sections. And then we'll have some conclusion and recommendations for future work. There's no definite information first available about the church foundation date. However, the most credible estimation was in the second half of the 11th century. The church itself was constructed with something called bruletto. Bruletto is a medieval word. It means the garden enclosed by wall. And you can see from this picture the green part, and on the left, which is the church itself. And this is like a schematic for the draft for this location, or the geographical location. And in the 11th century was the estimation for the construction of this church. By the 13th century, there was a couple of buildings that were built behind this church. One of them was the Palazzo del Pretorio. And these were like a local high officials buildings, and they reached to the Duomo. Duomo is the building on the right, which is the tall building on the right of these 2 red buildings, as you can see. And a substantial portion of the Bruletto, which was the green area that we talked about a while ago, was removed due to these 2 buildings built afterwards. In the 15th century, there was no change in the church of San Giacomo, as you can see on the left side of the photo. However, the work in the Duomo itself was remaining like they started to build and to add more elements to the Duomo, or the Basilica of Santa Maria Maggiore, which is the orange building on the right. On the late 15th century, the municipality of Como, they started to pay for restoration work for this for the second intervention for the church of San Giacomo and the area surrounding it. And they started even by demolishing some of the areas between the facade of the church itself and the Palazzo of Pretorio. And you can see from this slide that even the start or the beginning of the church itself, it was removed due to the expansion of the road that was created for public use. And the final shape of the Santa Maria Maggiore Basilica was the shape, as you can see in this photo, which is the yellow building. But our church is the red one on the left. But this history, just I'd like to, I had to say it so you can know the history of the building. And now this is the final building that exists now in this area. Of course, these are some pictures for the real building in life, and some of the buildings surrounding it. This is a Duomo and the Palazzo. Of course, on the left side, left down, you can see the remaining buildings for the historical building of the municipality. The building went through 3 major renovations. The first one was in 12 years of degradation after the construction. The structure was repaired and altered, changing in its original form, of course. And the cross vaults were created in the central nave, and domes octagonal lanterns were removed. The second renovation was, or intervention, was in the early 18th century. It was the lantern in the middle of the dome. It was in danger of collapsing the whole dome, so they decided to make an architectural renovation, historical worth. And of course, the octagonal form of and the 8 tough oculi and mullioned windows were repaired as well. The third one, the third renovation or intervention was, or it will be this year, and earlier this year, they decided to make some state-of-the-art modern renovation for the whole church, because of course, after almost 600 years of building, the building itself become more and more deteriorated. The method of research thesis, it was using a qualitative research investigating the feasibility of constructing an HBIM model from point cloud file, as well as reverse the engineering process of design in order to examine the roof's resilience toward the stresses that which the building is already currently being subjected to. The methodology itself was chosen for the research project in order to obtain reliable results that are relevant to the aim of the objectives of the intervention or the investigation. The heritage building itself, as you can see, I'm sorry about this. The heritage building itself can be preserved by creating a 3D model that contains all the thematic information, of course, and through a modeling authoring tool, as for my case was, of course, the Revit tool that saves all the scan to BIM metadata. And to acquire all the data needed for the model, the level of detail must be considered to capture the building geometrical elements of course, with the use of laser scanning model, photogrammetry, and the heritage documentation, and so on and so forth. As you can see, we have 4 stages. The first one was the collecting the data, scan to BIM, data mapping, and then at the final result, which was the outcome. Of course, at the stage of the data collection, many paper was explored, and the data collection procedure, I had to make research through the building historical documentation, of course. Of course, this building was in the 11th century, so the data was really scarce in this situation. So I needed to have like more trustworthy heritage information, such as information as to be architectural material used for the building, or the time, how is the historical record from the building library, and so on. After data collecting, of course, I need to have some scan to BIM models. And of course, I got some point cloud files, of course. The point cloud files with the photogrammetry by drones were provided for me. And I had to manipulate these data through a model and add some complex geometry, maybe by modeling numerous ways, and use maybe some using families inside the model itself. For our case, this model was less complex, so I did not need to do any dynamo scripting or any advanced modeling. So the whole purpose was to make it as easy as possible to model these kind of existing buildings into 3D model, but using more like affordable ways to do it, or without any knowledge of advanced modeling techniques. So by this, I created some sort of a digital library for modeling the approaches of the parametric geometries, of course. And the model includes the relevant heritage information with the visual and text representation of all the elements. This is that was really useful for integrating the heritage management in the future. And the model was a complete mirror, and mimicking all the current building and store all the maintenance information as is now. After creating the HBIM model, of course, we have to consider that this building needs to be, I need to have an outcome, which is the HBIM model, of course, that will be used in so many ways to verify the safety of the building, safety of the masonry used, of course, the maintenance in the future, or maintenance plan in the future, how the management system of the building, how the scaffolding installation in case of the renovation, and so on. So I made a schema. The schema was about to, of course, it was divided into 4 stages as the previous method that I used. First one was the collecting the data, of course, by studying the documentation available, of course, and identifying the purpose of the building itself, the construction-wise of the building. The second phase was scan to BIM, which providing the photogrammetry, photography, drone survey, laser scan, and so on. Some measurement, of course. I needed to go there and take some measure tapes by myself. And after capturing the whole building geometry, of course, these data need to be manipulated or mapped through a model authoring software like Revit, of course. I needed to identify the model granularity, the level of detailing, the level of information need, so I can build a geometry or a model that's going to be approved. And after the approval, of course, if there's any further investigation, the loop going to start from the beginning, from the data capturing, if there's something missing inside the model itself. The second stage of this workflow, or the fourth or the last part of this, is the outcome. After making the model itself, we need, of course, to identify the load paths. Me as a structural engineer background, I needed to have something like checking the safety of this building. So in order to check this, I need to have a load, of course, load pattern, so I can check the safety of these loads on this structure, of course. And that was by calculating the weights of the building, calculate the loads subjected to the building itself, and then check if there is a visible defects or deterioration to the sections. If there was, of course, we need to make a repair, and after the repair, you need to go through the whole identifying for the load path from the beginning. And if there's not, of course, you go with the truss analysis, because the roof was a truss system. Truss analysis, calculate the loads, and then you have to compare these data with the existing loads, of course. By everything was computerized by computer analysis. So after this, you design the section, check the safety, and then you go with the structural integrity of the model, and then you finish the whole process. This is in a nutshell, but of course, we need to know more about the building itself. So in this screen, you can see the building itself. It has two types of frames. Our scope was to renovate, or my scope at least, was to renovate the roof only. I have other colleagues, they were working in PhD studies. They would have the rest of the elements, but mine was the roof, of course. I had two main sections. First one was the end section that you can see on the right screen, the top, the end frame section. The left one was the king post frame. The one on the right is the original frame that was made in the early 11th century. The second one on the left was the newest, which was, of course, it's not new, it's old, so old, but this is the newest. It was in the 15th century. So we have two old frames. One is the older than the other. The old one is not carrying in loads, so it was just like a put in there just to preserve the heritage itself. But the second one on the left was to carry the loads over the roof, of course. Of course, when I started to make the BIM documentation for this process or this project, of course, I need to make a model granularity. So, of course, as I said, we need to make some model segregation. Mine was only the roof, others had the other models. So we need also to make working or breakdown structure, the element breakdown structure for the whole elements inside the pieces. Second, we needed to make identify the level of detailing. Of course, this is an existing building, so of course you need to have LOD 500 according to the BIM Forum 2021, which is the latest so far. And after defining the LOD 500, and of course we all know that there is no such thing as LOD 500, so that the one like after it is just like the LOD 400, which is done for as-built. But of course, as-built is similar to the existing in this case. So yeah, I used the LOD 400, of course, for the level of detailing. As the last thing was identifying the level of information need by using the codes for the heritage building, like the ICOMOS, or the ISO for the BIM, of course. So we need, of course, to define the model purpose and the geometrical level of information, alphanumeric level of information, documentation level of information, and at the end, you will get the level of information needed for this model, in addition to the naming convention for all the elements and all the files used in this project. For data collection, of course, by going to the field and measuring some elements in the site, you will find some elements that I needed to take care of the level of information or the level of accuracy in the model. Of course, this is heritage building. You need to capture every single elements inside the model, and the higher level of accuracy you get, the more benefit you get at the end. So of course, after getting some dimensions, you can see there's a picture that I was taking some drafting about the dimensions that I took by myself on site, and some sketches that I drew for the angles, the dimensions, the cross sections. And of course, by reading, you can see in the lower part, reading some documentation, old documents about how the technology of the construction or for these kind of frames used to be in the previous or the early days of these construction days. Of course, all these layers of wood or stone or whatever the material used was implemented inside the model authoring tool, as you can see from the screen. Of course, I had to do several iterations. These are the major iterations that I did, and I can summarize them in three major iterations. The first one was to use the out-of-the-box families inside the modeling authoring tool itself, which is the king post truss. Of course, I had some problems faced because, of course, the point cloud has the real deformation for the elements. So, of course, this is really idealistic scenario. So it's not matching the thing that I'm using now. So I needed to make some intelligent elements. So I created families by myself. So these parametric families were supposed to replace the existing family in real life, of course. But as I said, it's still constrained due to the more deformation that I found in the middle of the roof, because the more you get into the roof itself, the more you found more deformation and more deterioration due to the existing load. Of course, the third one was to divide them into two frames. Of course, yeah, if you have a major problem, you need to decompose it into small problems. So that's why the strategy that I followed, just to divide these two elements into two frames, one on the left and one on the right, with the parameters that I have. The final product was, as you can see, two families, one on the right, one on the left. I adjusted all the section, the orientation, the cross section, angles, of course, because you have this kind of twist inside these models. The angle of the inclination here, you can see it, of course, the frame offset from the right and the left for support location. Of course, after I finished this, the final result was, as you can see, the frames itself on the left side, and after I added so many the purlins and the other underrafters and the other elements on the right. This is the other trial for the older, or the very old, or the original frame, the N-truss. Of course, I used the out-of-the-box family that was exist inside Revit, which is the N-truss itself. I removed some elements, some adjustment was made, and of course, you can see the difference between the original frame on the left and the final product that I obtained after modeling the truss itself. Of course, this is the manipulating for data taken through the point cloud, and the final result that you can see from the top right angle of this screen, you can see the final result was matching the drone and the point cloud, of course. And
Mohannad, yes. Please, you have to speed up to finish. Okay, your time is done. Thank you.
Okay. Just a few minutes. Of course, I added some many materials. Of course, this is the final result for the church itself, the bell tower, and these are the data extracted from the model itself. These are some showcases for the stuff. Of course, I needed to have some material recognition for the material used inside the model. So I made some investigation about this material, and by geographical location, I obtained the material to be oaks and larches, and of course for the stone, through some researches also, I got this stone called serpentine, which was made for the roof stone slates. Of course, I got the mechanical properties for it afterwards, and then you have the metallic, the metal details for this brackets for this frame as well. And I needed to make some checks, structural checks, of course. So I made some structural analysis for the frame itself with the loads, supporting loads to it, and exported through Revit into another software, which was SAP 2000 by an extension. And then I designed these sections through these, of course, the straining actions obtained, and designed these sections through a Wood Express tool, which was designing the wooden elements through the Eurocode format. And of course, I made some SWOT analysis for this process to obtain the strengths, weaknesses, and opportunities that was in this this study. Of course, the stresses, I'm not going to go and elaborate into this so much. Everything was inside this slide. The whole process is really unique, and of course, you can see that most of the elements were digitalized from the real life into Revit models, so you can use it in multiple software, of course, and you can make a lot of interoperability between one software into another, which was really helpful for me to jump from one step to another, of course, and to help me at the end to find the final product. Of course, creating this model, I made creation for the model, estimation for the weights and the loads, of course, of the elements. And this model can be generating a bill of quantity in the future. Maybe you can make maintenance plan. Of course, I do recommend in the future when they are using, because they're about to renovate it, there was another suggestion to have some wireless sensors inside this model, so you can detect the movements of the roof itself through some data analysis and the machine learning. Of course, this in the future by using the digital twin that was created through the HBIM. And of course, that's another suggestion for the naming convention, because this project is supposed to be bigger than the size that it was meant to be done for. That's it. I'm sorry for being long, and thank you for your attention.